Can we just touch on that? Because
Yeah. Yeah, we did it last time.
I mean, it's not the same problem, but maybe it's like a different problem.
Let's choose one. Those are in section 1.7. Anything you want. 1.7. Inequalities. Are these steps here clear, everyone?
Yeah.
Remember, you can, if you have an equation and you are asked to solve for a variable, you should always try to solve for the variable. In this case, it was a function. But so what?
I just didn't know you can plug it in there.
But you have to think what's behind the process, right?
Mm-hmm.
F comma G equals H, and I have to think, okay, what is this on this side? What is the other side? Okay, now let's look again at both sides and see, oh, okay, F comma G, I plug G in F, and so on and so forth. Take it slowly. Okay, so which problem are we looking at?
One of these, can we do 70?
70.
On page 80.
70 on page 80, of course.
It was the addition and subtraction.
70. Very good. So we have 1 over x plus 1 plus 1 over x plus 2 less than or equal to 0. What is the first step when I'm asked to solve an inequality? What is the first step that goes through my mind? The first thought?
So if there would have been one on the opposite side, just move everything to the...
No. The first step is?
It's going to be 1 over x plus 1 plus 1 over x plus 2 is greater than or equal to 0.
What is the first step?
What can't be x?
Say it again.
Make sure it's equal to 0. Or it
What can't be x?
Nope.
I thought the first step is where you find your domain, where you're saying...
Nope. I need a domain when I graph, and when I'm asked specifically domain. Nope. You're giving me this, right? And you say solve it. What is my first thing?
LCD?
Nope. My first thought is I'm looking at it and I ask myself, what is it? Because if I don't identify it correctly, I will not know what to do.
Rational inequality.
Right? Okay, so it's an inequality. Then now the wheels are turning. I cannot multiply both sides by an expression with x. There is no need to state the domain because I have to have everything on one side, find the least common denominator, change it into a product, and use the chart if I want to. So this is what goes in my mind right away. What is it? If I use the chart, then I have to have 0 on one side. Then I have to find the LCD. I have to fully simplify it and study the sign of the top and the bottom. So right away, because if this were, for example, linear, I would have said, oh, it's linear. I'm going to move terms with no variable to one side and terms with variable on one side, and I'm going to divide, and I'm done. If it's, and we'll see later on, if it's other types of inequalities, then, but first I have to identify it correctly. Okay, perfect. Rational indeed. I know that I cannot eliminate fractions by multiplying both sides by blah. Okay. There is no need to find the domain, although it's not wrong, but there is no need to find the domain because the chart will give us the domain in this case. I'm not graphing it, and I'm not asked to find specifically the domain anyway. Good.
So LCD.
Yes. Correct. Indeed, x plus 1, x plus 2. Adjustments for the top.
X plus 2, x plus 1.
So the numerator becomes? Good. So then the numerator becomes? The denominator does not go away. Be very careful. Okay, is this chart ready? Yes, because the chart requires, if you want to use it, requires a product or a ratio. And remember what I'm doing now. I'm studying the sign. Study the sign of this expression. Not yet. Not yet. I have not studied the sign yet to make a decision yet. So what numbers go in the chart? I know the factors that go in the chart. Which factors go in the chart?
1.
2x plus 3, x plus 1,
X plus 2.
yes. And what is the last one?
The
Yes, or the ratio in this case, because this is what I'm interested in. Perfect. Now I'm asking myself what?
What zeros about?
Exactly. Which numbers make each factor 0 and they have to be in ascending order?
So,
Okay, which numbers?
negative 3 half.
Correct. It's not the first one. That's because it's negative 1.5. So I have to have negative 2 first, negative 3 halves for next, and negative 1 last. Be very careful because if we mess this up, we mess up the answer. So this is negative 2. From here we have a negative 2. From here we have a negative 1. But from here we have negative 3 divided by 2, which is negative 1.5.
Okay.
And now I put the zeros. 0 here, 0 here, and 0 here. That's my next step. Then I have to determine what happens here, here, and here for the ratio. Under negative 2.
Be negative since it's on the.
Under negative 2, it cannot be a sign. Under negative 2, it cannot be a sign.
Undefined.
Exactly. Under negative 3 halves
can't be 0. So
This is 0.
is 0. The fraction is 0 and the top is 0.
And then negative 1 is undefined.
Exactly. I need these thresholds because if I don't have these, then I don't know where the sign changes.
Okay. Oh, okay.
So these are the key, and of course here. So now there is nothing I have to really think about because all these three look like this. They are linear functions with a positive slope. So the sign must be negative first, 0 next, negative and 0, negative and 0, and then positive. I see 1, 2, 3, 4 subintervals. The sign of this expression on the first subinterval.
Positive. I mean negative.
Yes. The sign on the next subinterval. And on the next. And on the next. Good. Only now I look at this.
So now we're looking for just the negative.
Exactly. Only negative is less than or equal to 0. Where is this ratio negative?
From negative infinity to negative 2.
So x in the interval negative infinity to negative 2. Do I put a bracket or a parenthesis? I can't because it's undefined.
Even if it's less
It's
than.
undefined.
Okay.
I can't ever close negative 2. The
Okay,
expression
so
doesn't
negative.
exist.
Okay.
Exactly. And then union.
And then parentheses, negative 3 half.
But negative 3 halves is 0. I can use the bracket now. Negative 3 halves, comma.
Negative 1 bracket. I mean negative 1 parentheses.
Exactly, because the expression is undefined. Very good.
That one was easier.
Yes. So that's why I'm highly recommending redo all problems we did in class for the test. Okay, anything else?
Okay, sorry, I just want to do one more like that.
Yeah, no.
Okay. Can we do 66 as well?
Okay. So 3 divided by x minus 1 minus 4 divided by x greater than or equal to 1. Okay, what is my first thought?
What kind of problem?
What kind of inequality is it? And the answer is
Rational.
rational. I know that if I need to use the chart. If you want to use the chart, then this is not the only method. But I want to have 0 on one side and a product or a ratio on the other. I'm not asked for the domain. There is no need because this will tell me the domain. See, this was very clear.
Mm-hmm.
Okay, and what else? I cannot multiply both sides of an inequality by x or x minus 1 or even the product. I cannot do that because I don't know if it's positive or negative. I don't know when to switch this symbol.
Yeah.
So what will I do first?
Get 1 to.
Exactly. I think I chose this. I think this was what we had on the quiz, I think. I'm not sure. Or maybe similar.
And then we find LCD.
Okay, I have to find the LCD. Good.
X minus 1 is x.
Yes. Good. Adjustments, please.
So 3 gets an x. 4 gets x minus 1. And then 1 gets a x squared minus x.
Exactly. It has to get the whole product. Very good, because it has 1. Very good. Excellent. So now, can anyone dictate the top? See, this at this point in time, this should be routine.
So 3x minus 4x plus 4 minus x squared plus x.
Very good. Do we all agree with the top?
Yes.
Good. Now I have to arrange it in descending order, which is negative x squared, negative 4x with positive 4x plus 4 over x times x minus 1. I realize that the the numerator is in descending order, excuse me, but it has a negative leading coefficient. I will pull it out
So you can pull out the negative.
from any expression I want. As long as what I write makes sense.
Do we need to
Yes,
do the top?
yes. The keywords are factor, simplify, factor, and simplify, yes.
So
However, I would like to multiply both sides by negative 1 because I don't want to worry about this. So then I have x squared minus 4 over x minus 1. What happens now?
the sign of this.
Yes. And now I can factor the top. How?
X plus 2 and minus 2.
Very good. I hope you understand and we all agree solving this is identical with solving this. They are the same. Solutions will be the same. I shouldn't say they are the same. They don't look the same, but the solutions will be the same. Okay, now this expression or this inequality is chart ready. I have a product of 4 factors here, or ratio product, and 4 factors. I have 0 on one side, so I can study the sign of this expression. First I study the sign, and then I look and see what I want to pick, or what I need to pick. So let's do that. X is the variable in the problem. But it happens that x will be also a factor. So x plus 2, x minus 2, x minus 1. And of course, you always know that I run out of room, so I'm going to write ratio. X is anything. And now what are the values from left to right in ascending order, in other words? Negative 2 is the first one.
0,
0 is the next one.
1,
1 and 2. Now I have to put the corresponding zeros. 0, 0, 0, and 0. Then I have to put the corresponding zeros in the ratio. Under negative 2, what happens?
0.
Yes. Under 0, what happens?
It doesn't exist.
Undefined or doesn't exist. Very good. Under 1, what happens? Undefined. The denominator is 0. It cannot be 0. And under 2,
0.
0. Now, this is straightforward. I don't have to do much. I know it's a lot of writing, but I don't think it's difficult. You can use any method you like. Okay, here's what I'm going to do. All these are linear functions. I hope you agree. Because if they are not linear functions, I cannot assume anything about the sign. But since all 4 are linear functions with a positive slope, they have to do this. It's a must. Now, one time a student asked me, how many minuses do I put? You don't have to put any minuses. Just write negative if you don't like to put minus. I like because it's easier. And positive. Whatever you want. I prefer this. It's so much easier than reading that positive. But it doesn't matter, whatever you want to do. So I have 4 negatives on the first subinterval. I have 3 negatives on the second subinterval. I have 2 negatives on the next one. I have 1 negative right here. Be very careful. 1 negative. And I have no negatives. As you notice, I don't even count the positives. I only count the negatives because only the negatives will change. Could change the outcome. The positive doesn't mean anything. In the sense that, okay, only now I'm asking myself what is less than or 0 so I know what to pick.
So negative.
Negative. So I'm looking at this and this, which means this and this.
So bracket between the two.
Yes, bracket -2, so x in the interval.
0.
Exactly. I cannot include this ever for whatever reason. I can never include it because the expression is undefined. Union,
And parentheses 1, bracket.
yes. I thought that this would be easy because it's like a puzzle. But everything needs practice. I know that. Okay, anything else?
Yeah, I had one for doing for a piecewise function.
Yes.
So for on page 160, I think it's number 40.
Page 160, number 40. Number 40. F of x. And we have -1 x or 1 for x less than -1, for -1 to 1, and for x greater than 1. Perfect. Now this is a different story. Here I'm asked to graph. Okay. What do I do first when I'm asked to graph anything?
Find the domain.
Exactly. I have no choice. I have to start with the domain. Good. But since it's a piecewise defined function, I would like to solve those inequalities and write the interval notation and then make a decision on the domain. Yes?
Can we just plug it in? Do we have to solve it, or can we just plug it in? So if we -1, wouldn't that be just like 1?
Right. But I truly recommend presenting a chart because these piecewise defined functions can get very hairy. So, okay. So the interval for this.
So
It's negative infinity to 0, or -1 without parentheses.
This interval.
-1 comma
And this interval?
1 to positive.
Now I can conclude something about the domain.
The domain is negative infinity to positive.
Do you all agree with negative infinity to infinity, all real numbers? Everything between negative infinity and -1. -1, everything between -1 and 1. 1 and everything between 1 and infinity. That's why I wrote this.
Right.
Because this may be slightly more difficult, but since we wrote that, it's, I think, better. Okay, so now this is x, and this is f of x, which x values must be in the chart no matter what.
-1.
Exactly. Good. I have the symbols under -1 right here. A parenthesis to the left and a bracket to the right, and they are touching. What are the symbols under 1?
Bracket to the left, and parentheses to the right.
Which function do I use for the first interval, for the second interval, for the third? You have to be very careful because these don't have to be presented in order from left to right. They may be presented totally differently, and you have to identify it correctly.
So -1.
So this is a -1, I agree.
Then that's x.
I agree.
That's just 1.
Excellent. Good. So now I know this is a linear function. I know this is a linear function. This is very important to analyze because it happens that these functions are like this, but you may not encounter a piecewise defined function made only of linear functions on each piece. Good. So linear, linear, linear. I only need 2 points for each. Okay, I'm going to say -2. When x is -2, how much is -1? How much is the function?
-1.
Thank you. When x is -1, how much is the function?
-1.
Good. On the other side, and you should say here, you can't. You can plug in -1 in this. Well, of course I can because it's just a number, but I can because I shouldn't be allowed to because of this, right?
Right.
Okay,
Maybe a circle,
Okay, so
right,
where
a
did
full, I'm sorry?
Where did we get the coordinates from? So we have -1, you plug that.
So the function is for whatever x, the function is -1. No matter what you plug in, it's -1, nothing else.
So it's like y equals -1.
For any x value,
Uh,
y is -1.
Okay.
-1, -1, -1, -1. Anywhere.
So you picked a point after -1, because I was wondering where the -2 came from.
I picked the x value to the
Yeah,
left of
that's-
-1.
Yeah, okay.
You pick any value you want. Okay, on the other side, plug in -1. What do we get?
-1.
Plug in 0.
0.
Plug in 1.
1.
Good. On the other side,
1. 1. Okay.
good. So let's graph this function. Remember, you cannot graph something like this. Overlapping, extended.
Oh, and he's what?
On each piece, you can only have one graph, not several graphs overlapping. Be very careful, because that's what I saw. Okay, ready? First ordered pair. -2, -1. Good. Next ordered pair. So -2, -1. Yes. And this will be an open point. And that's it. However, now I have to fill it in because I started the same point. So I have to fill this in. 0, 0, 1, 1. Full point. And then 1, 1 starts at the same point. These numbers are the same. There is no gap here. And then 2, 1. Can anyone give us the range of this function?
-1, 1.
Yes. -1, comma 1 with a bracket. That's all the range is all about. Everything between -1 and 1. Perfect. I don't recommend jumping and writing and presenting a point with no explanation whatsoever. So either use this method or something else, not just say, okay, I can picture this in my head. It's a point here, it's an open point, a full point. That's not legitimate.
So it's an open point if it's greater than or equal to or less than or equal to, correct?
It cannot be if it's less than or equal to an open point.
It's the only reason we close it in is because the graph overlaps. We had to
Right,
take it.
these numbers are the same.
Gotcha.
This would have been an open point, -1, -1. But since it's here on this side, it starts at the same value, I have to fill it in. Is that okay?
Yeah, but then is it because of the parentheses there it's an open point, or is it because there's a bracket?
They are the same number, that's why there is no open point.
In general, what defines an open point versus a closed point?
Parenthesis, if it's not equal to.
Gotcha.
If it's equal to, it has to be a full point.
Okay.
The function exists at that point. But if it's a parenthesis, the function does not exist at that point. It will exist as long as the next one starts here. If it starts at the same point, then it's closed. Okay, anything else? Any questions on the modeling?
Yes.
Okay, let's look at the modeling.
Number 3. Actually, all of them. Number 3.
My rectangular box has a square base. So we are looking at problem 3 on page 218, and we have a rectangular box with a square base. I'm going to call it X everywhere because the base is a square. So now it says its height is half the width of the base. So then the height equals 1/2 x. Find a function that models the volume. They call it W for the edge. I called it X. So the volume of something like this is the area of the base multiplied by the height. Area of the base is x squared, and the height is 1/2 x, so the volume is x cubed over 2. Anything else from modeling?
Can you go over that one more time, please?
The area of the base is because it's a square, is x squared, and the height is 1/2. It's given in the problem that the height is 1/2 of the base. So the volume of this room is area of the base times the height. The area of the base is x times x, which is x squared, because that's the area of a square, multiplied by the height, which is 1/2 times x, which makes it x cubed over 2.
Because it is a square. It's length times height, length and width is the same over square, x squared, correct?
The area of a square is x times x, which is x squared. Anything else from modeling? These are all problems from the previous course, so I'm willing to do anything you need.
Is it number 27?
Number 27. Area of a box. An open box with a square base is to have a volume of 12 cubic feet. So it says the volume 12 cubic feet. Find a function that models the surface area of the box. So the surface area, and it says an open box with a square base. So the same thing we have here. So it's the same graph or figure. So this is unknown, and this is x and x and x and x. Because it says, one more time, an open box, so there is no lid at the top, is to have a volume of this. And it has a square base. So as we just noticed, the volume will be area of the base, which is x squared times h. And here we're asked which equals 12. So this is our first equation in the problem. And we're asked to find a function that models the surface area of the box. So can anyone give us a definition or a formula for the surface area? There is no lid at the top. Now, I would include the base.
So 1/2 x squared.
So I have 1, 2, 3, 4 faces, base times height, so 4x times h, plus the area of the base, which is x squared. So the only unknown, in a way, that I have here is h. So I will have to take it out from here, which is 12 over x squared. And all I have to do is just plug it back in. Because I'm asked to create a function that represents the surface area of the box. And of course, it's a function of one variable only. So therefore, s equals s of x, it's a function of x. So I have 4 times x multiplied by 12 over x squared and plus x squared. Then I simplify by x. I can, because x cannot be 0. So then I get 48 divided by x plus x squared. But we knew all these, right? From the previous courses. We remember any of this? Part B, find the box dimensions that minimize the amount of material used. This particular question is a topic for chapter 3. However, let's discuss it now. Find the box dimensions that minimize the amount of material used. So what is the material used? How do I determine that? So imagine this is my box. Assume it has a square base. And I want to determine, it's open. And I want to determine the minimum, so the dimensions that will create all this surface area to be the minimum, because the surface area is the material that I use to create the box. And I have the function that gives me the surface area. No. So I have the function. So basically in part B, I'm asked to minimize s of x. Now, I'm sorry.
So just find the minimum of the problem.
Yes. Find x, which is the base, the dimension of the base, and the height, such that what?
X times the
S of x is
It's lowest.
exactly the minimum. So this is the question. Also, if you want, we can find that minimum of the surface area. However, we are asked now to find x and h, the dimensions, which are right. What? The size, the length of the base, right? And the height that will give us the minimum surface area. And we do have the function. This is the function. Now, my only chance in pre-calculus is to graph this function. And I will show you how to graph it, and I will show you how to determine the minimum. However, I have to look at it and think and decide about the domain. True. So this is our function. Let me write it here one more time. S of x equals 48 over x plus x squared. First of all, what does x represent in my function?
height.
The-
Or sorry,
The length of the side of the base of the square, right? Good. So I know that the entire volume of the box is 12. What are the minimum and maximum possible numbers that as x can be? Of course, you already said x is a distance. It cannot be negative and it cannot be 0. If the distance, the length of the base is 0, then there is no box.
So I guess the factors of 12.
So 3 and 4.
So what is the, which it cannot even be, but what is the maximum that I should graph this function on between 0 and
12.
absolutely. It's not possible that the base is 12, right? Because 12 times 12 times 12, it's way more than 12.
Mm-hmm.
So not even 12 if you consider that. But let's graph the function on 0 to 12. But I have to think in these terms because I don't know where to graph the function. Ready?
Mhm.
Of course 12 is way out there. I have no idea also how high the function will go or how low the function will go, but I'm only interested in the the piece between 0 and 12. So 48 divided by x, and then outside plus x squared. Ready? So I will look at the viewing window. I only want 0 to 12. Definitely, I'm not talking about a negative surface area, so I'm not going to consider anything below y-axis, right? Because y is our s of x, and it's a surface area. I cannot have a negative surface area. I don't even want to see anything below the x-axis. And I have no idea how high to go. For now, I'm going to say 50. Okay? So I'm going to say graph it. So 0 to 12, scale of 1, scale of 1. I'm going to use 10. Okay, graph. So, as you see the graph, if you want to see it even higher than that, we can. Let's put 100. Scale of 10. Let's see what happens now. It's very clear. Between 0 and 12, the function has a minimum. Where is this minimum? Definitely somewhere between x equals, remember I have 100 here, and this is 10, 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 right? So somewhere between 10 and 40, right? So I will say second and calc. Which item do I pick? Minimum. So I pick number 3. And the calculator will ask me, okay, where do you want me to look for your minimum? So I'm going to say I want you to look for the minimum between 10. Oh, of course. Sorry. We are between 0 and 12. So the minimum. So 10 is here, 10 to 100. So between 1, 2, 3, so between 1 and 4. Okay. So the left bound I want 1, and it will show me where I put it. And the right bound would be 4, and it will show me where. So now I know the calculator correctly is looking for a minimum between this point and this point, because I gave it that particular domain where to look for it. And when I click enter, because I don't want to guess, it will tell me where the minimum is. So what should the base of this square be in order for guaranteed surface area to be minimum? And I can determine the surface area minimum, which is this, 24.961 cubic feet. So, because everything was in feet. Am I correct? Am I correct? Everything was in feet, right? Yes. Okay. So then I have the minimum. I'm going to write x equals 2.884 feet. And if you want, the minimum surface area is 24.961 cubic feet. This is not sufficient. Because look what the problem is asking us to find. Find x and the height. So find the length of the base and the height. But that's not a big deal because I have the height as being 12 divided by x squared. So therefore I have h equals 12 divided by 2.884 squared. So I go back to my calculator. I get out of that window. And I have 12 divided by 2.884 squared. And I got that the height of this box has to be 1.44 cubic, 1.44 feet. So h equals 1.44 feet. Any questions? Any questions?
Are we going to have to know all these formulas for like
These are common sense, really. Like the volume of a sphere, for example, volume of a cone, volume of a circular cylinder. For a cylinder is the same with the box. Area of the base times the height is just that the area of the base is a circle. Exactly.
area of cones, 1/2 power squared?
Say it again. The
Area of
cone.
cones?
Yes, it's 1/3.
1/3.
1/3. 1/3 of the volume of a cube of a cylinder. Okay, I want to go back here to this handout, and I would like you to select from the difference quotient. And from these functions, because as you see, there is also 4.3, but we haven't gotten to chapter 4 yet. So look at those. And also these. Okay? So this is the additional suggested exercises. And I would like you to select a problem from each, so we can work on it as part of our review. And then I would like to practice with these problems from the other handout. Okay? So this is from Simplifying an Expression handout, but I would like to work on one problem from each, these 3 sections, and then continue reviewing. Have you figured out which Tuesday you're going to, which will be our first Tuesday to make up the Labor Day?
What Tuesday works best for you?
Well, what about next Tuesday? Because we're going to have the test on Wednesday this week.
I can do next Tuesday?
That's Tuesday of October what?
Third. Yeah, that's fine.
Can we do 4:15 to 6:15 p.m. in this room Tuesday? Can everyone make it? Chris?
Hardest to get here at 4:15.
Okay. Chris, can you make it?
I can try.
Okay. Because
I have a class that ends at 4, so I can.
in this building?
It's close. This one by the.
Oh, just across the street.
Yeah, it's one on.
The ACC campus. Yes, cybersecurity campus. Okay. Okay. Very good. So now, if you want, I can make it 4:30. Is 4:30 better?
4:30 for me is a little better.
Okay, that's fine. That's fine. How is that? Everyone, 4:30 to 6:30?
Yeah.
It's just that if you could come like maybe 5 minutes earlier than 4:30, because I have a class that starts exactly at 6:30 in this room. So I don't want to overlap.
Maybe a little bit later, but I should be able to make it around.
Okay, so I will remind you again next Tuesday. Okay, and then we'll talk about the other Tuesday
What
later.
is this for?
We are because we missed Labor Day. That's 2 hours. I'm going to continue with the material. Yes. Okay. So have you selected? Find the difference quotient. We did a difference quotient, or we worked on a difference quotient for a lot of rationals, and these are radicals. So there are two different functions: radical function, rational function. It's up to you. Okay, which one? C. Very good. So we have f of x equals the square root of 7 minus x. We're asked to find and simplify the difference quotient. Okay, let's do it. Do we remember the difference quotient?
That's x plus h minus x over h.
Very good. What piece I don't have, and can anyone give it to us?
Yeah, so it's x plus h. So it's going to be square root of 7 minus x plus h. X minus h.
Yes. You either say minus x minus h, or you say minus x plus h in parentheses. Very good. Minus.
Minus square root of 7.
Good. So what do we do? Any suggestions on how to simplify this?
Can we back up a sec? How do we get the 7?
F of blah equals 7 minus blah. So if I put in here x plus h, then I have to put in here x plus h, and I have to distribute -1.
Okay, I got you.
Good. So then what do we have? What do we have to do next in the next step? How do we continue?
Get rid of the radical.
Good. How?
By square.
I cannot.
Okay.
This is not an equation. Very good. I square both sides if I have an equation. All of a sudden, I cannot say, okay, let me square.
Yeah, so it gets next.
Good. So then something else must be available.
Rationalizing.
Exactly. Exactly. Absolutely. We normally rationalize the denominators, but now we really need to rationalize the numerator. So that's a special case. Very good. So then how do I rationalize the numerator?
So maybe square root of 7 minus x minus h plus.
Exactly. Thank you. And both top and bottom have to be the same, because this is 1. So we know that, right? Good. So now we are applying one of our products from the agreement on the first day of classes. So tell me what to write at the top. I copy the denominator.
So the square root is 7 minus.
So what do I write?
So minus x minus h minus
Very good. Because remember, it's a squared minus b squared. So if this is a minus b, and this is a plus b, this must be a squared minus b squared. That's our agreement. First day of classes. A plus b times a minus b, or a minus b times a plus b is a squared minus b squared. So you have minus this quantity squared, but you have to distribute -1. Do you all see this?
I understand the contract we did,
Right.
how that works. You rationalize a numerator. How does that work? I'm drawing a blank here. I probably know this, but I'm drawing a blank. So
I multiply by 1 in this form with the conjugate of the numerator. And then when I multiply a minus b by a plus b, I get a squared minus b squared. That eliminates both radicals.
No, just simplify. So,
Right, is this okay?
if that's fine.
Now, if you want to write negative outside and in parentheses 7 minus x, if that's easier for you, you can.
Yeah, that's
So minus and put in parentheses 7 minus x, and then distribute -1 in the next step. Would that be better?
Yeah.
So you will write 7 minus x minus h minus 7 minus x. And then you will have to distribute. And this will be your a squared, and this will be your b squared.
Okay, that makes more sense.
Better?
Yeah.
Okay, so what is the target? I should have asked that from the beginning.
get rid of the H on the bottom
Yes?
and get rid of everything that doesn't have H in it.
At least the quantities or the terms that do not have h in it. Maybe some other terms cancel out, but at least those with no h in the numerator. Perfect. So, do I get rid of anything?
You rid of the 7 and the X.
Of course, they don't have h. No, they have to go away. H at the top. H over, or multiplied by 7 minus x minus h with the square root and plus the square root of 7 minus x. And now, final step. Yes, so I met both my targets. First target is to cancel out all terms that do not have h in the numerator, which I did. And now the final target, or the second target, is to eliminate h from the denominator. The one that was alone, this one here stays. I cannot cancel that or eliminate that. So the simplified form is this. Any questions on this? Any questions? Okay. Do you think we need a rational? Or are we okay? Can we move on? I think we did so many rationals. Are
I'm
we?
okay with rationals.
I'm sorry?
I'm okay with rationals.
Oh, okay. Anybody wants rational, or can we move on? Okay, so find the domain of each function. Hold on just 1 second. I reached 48.